Hello, my dear children, and welcome back. I know, your exams are just around the corner, and some chapters can feel a little bit tricky. But don't you worry. Today, we're going to make this chapter, Interior of the Earth, so simple and so interesting that you'll remember every single thing. And hey, if you find it helpful, please let me know in the comments. It really helps me a lot. All right, let's start our little investigation. You've held a cricket ball, right? Have you ever wondered if our Earth is just a giant, solid ball like that? Or maybe it's hollow inside? It's a huge mystery, and today, you and I, we're going to put on our detective hats and solve the case of what's really deep inside our planet. So here's our plan of action, our detective's case file for today. First, we'll look at the big mystery of our Earth's secret interior. Then we'll gather our clues from deep inside. After that, we're going to talk to our star witness by decoding the earthquake waves. With all that evidence, we'll take a journey to the center. We'll also see what happens when the Earth gets angry, and finally, we'll practice some guaranteed exam questions to make sure you get full marks. This roadmap will make everything crystal clear, I promise. Okay, let's open our first file, Earth's secret interior. Now, the biggest problem for any detective trying to solve this mystery is that we can't just, dig a hole to the center of the Earth. It sounds simple, but it's totally impossible. And why is that? Well, because it's unbelievably deep. And the deeper you go, the hotter it gets and the more pressure there is. You'd be totally crushed. Just look at this number. The distance to the center of our Earth is over 6,300 kilometers. To give you an idea, the deepest mine we have ever dug is only about 3 or 4 kilometers deep. That's not even scratching the surface. So yeah, seeing it with our own eyes is just not an option. That's why we have to be clever detectives and look for clues. So this brings us to Section 2, Clues from Deep Inside. You see, since scientists can't go directly to the crime scene, that is, the Earth's core, they have to gather evidence, just like a real detective. And this evidence, it comes in 2 main types. First up, we have direct clues. These are things we can actually touch and study, like rocks from deep mines and the hot magma that comes out of volcanoes. But honestly, the really big secrets, they come from the indirect clues. These are things we have to analyze carefully, like meteors that fall from space or changes in gravity. But the most important clue of all, our star witness in this entire investigation, is the seismic waves from earthquakes. And that brings us to Section 3, Decoding the Earthquake Waves. Okay, get ready, Butcho, because our star witness is about to tell us everything. Earthquakes, as scary as they can be, are the single most important source of information we have. They give us a complete picture of the Earth's interior. So, what even is an earthquake? Imagine you're stretching a rubber band. You keep pulling, and then suddenly, snap. All that energy gets released. That's kind of what happens with rocks. The point where the energy snaps deep inside is called the focus, and the point right above it on the surface, where we feel it first, that's the epicenter. Now, this energy travels in waves. The ones on the surface are what cause all the shaking we feel. But for our detective work, we're interested in the body waves. These are our secret messengers, because they travel right through the body of the Earth. And there are 2 types we really need to know for our case, P waves and S waves. Now listen very carefully, children, because this is the most important clue. P waves, or primary waves, are the fastest. They go tuck, pushing and pulling, and they can travel through anything, solids, liquids, gases, you name it. But S waves, or secondary waves, these are the key to our whole mystery. They move side to side, kind of like a snake. And, this is the big secret, they can only travel through solids. They just cannot pass through liquids. And here it is, the testimony from our star witness. This diagram shows something called the shadow zone. This is an area on the other side of the Earth where our earthquake detectors don't pick up any waves. Now, P waves have a small shadow zone, you can see it, but look at the S waves. Their shadow zone is huge. A massive part of the Earth is completely silent to these waves. So, I have a question for you all. Thinking about what we just learned, why is that S-wave shadow zone so big? What could possibly be inside the Earth that stops those waves right in their tracks? Remember that big clue about S-waves? The answer is because the Earth's outer core is liquid. That's it. Remember, S-waves cannot travel through liquids. So when they get to this massive liquid layer deep inside our planet, they just stop. They're blocked. And just like that, our star witness has solved the case and revealed the biggest secret of the Earth's interior. Amazing, right? So the case is solved, which means we can move to Section 4, A Journey to the Center. Now that we have cracked the code from those seismic waves, we can finally draw a complete picture of what the inside of our planet actually looks like. And ta-da! Here it is, the structure of the Earth. And the easiest way to remember this is to think of a hard-boiled egg. The super thin outer shell, that's the crust. The thick white part, that's the mantle. And the yellow bit right in the middle, that's the core. Simple, right? Now this table is absolutely perfect for your exam revision. Let's quickly go through it. The crust is that thin, solid outer layer we all live on. Below that is the massive mantle. Now, an important part of the upper mantle is the asthenosphere. You can think of it as a weak, gooey layer which is the main source of magma. And finally, we have the core, which is split into two, a liquid outer core and a solid inner core. It's made mostly of heavy metals, nickel and iron, which is why we sometimes just call it knifey. Now for Section 5, when the Earth gets angry. Knowing about that hot, gooey mantle actually helps us solve another mystery, volcanoes. All that intense heat and pressure from the magma, it has to escape sometimes. And when it does, boom, you get a volcanic eruption. So you see, volcanoes are a direct result of what's happening deep inside our Earth. Now, sometimes the magma gets trapped and cools down inside the crust, but when there's a really massive eruption, the lava can flow for huge distances. A perfect example right here in India is the Deccan traps, which cover a big part of Maharashtra. Millions of years ago, huge flows of lava spread out, layer after layer, and formed that entire plateau we see today. Chalo, time for the final and most important section, guaranteed exam questions. I'm going to ask you a couple of questions straight from your textbook exercises. Let's see if you were paying attention. Are you ready? Okay, first question. Which of these is a direct source of information? Is it A, earthquake waves, B, volcanoes, or C, gravitational force? Now think, what did we say about things we can actually touch? And the answer is, of course, B, volcanoes, because we can directly touch and analyze the magma that comes out. Well done if you got that right. Okay, next one. This is a very important definition. What exactly is the lithosphere? Is it A, the upper and lower mantles, B, the crust and the upper part of the mantle, or C, the crust and the core? Think carefully about this one. The correct answer is B. The lithosphere is the solid, rigid outer part of the Earth, which includes the crust and the very top solid part of the mantle. This is a very common exam question, Butcho, so make sure you remember it. So if we have to summarize this entire chapter in just one line, it's this. The study of seismic waves, our star witness, is what gives us the complete picture of what our Earth looks like on the inside. And I'll leave you with a final thought to think about. Now that you're an expert on the Earth's interior, what do you think is the next big mystery for our scientist detectives to solve? What's the biggest question they still have about the Earth's core? Think about it. All right, that's all for today. All the very best for your exams, study hard, and if you like this, please share it with your friends. Bye-bye.